Hey, Visas, Daniel here. Who doesn't love basketball? Originally invented in 2010 by Mr. Sir Basketball, it is now played by at least 12 people in a small village named Naba Batun Ati, shortened to NBA. Now this information may or may not be true. I don't really have time to fact check. But what I am sure of, however, is that since the invention of the sport, people have been puzzled on what makes a perfect free throw. Today, I will be calculating this, as well as training an otherwise horrible basketball player in learning the art of the free throw. Firstly, let's talk about the many forces that act upon a basketball when it's shot. First, the applied force. This is the force that your hand exerts on the ball to force it to move in the intended direction. Next would be gravity. This is a somewhat uniform acceleration towards a planet, in our case, Earth, that has been calculated to be 9.81 meters per second squared. This force will always act down. The final force acting on the basketball would be drag. This force acts opposite to the motion of the ball. It can be described as D equals CD times A times 0.5 times R times velocity squared. CD being the drag coefficient, which is dependent on the force of the flow of velocity, the density of the fluid, the flow speed relative to the object, and the reference area and shape. A being the reference area of the object, R being the density of the object, and V being the velocity. Though every object exerts drag on Earth, assuming we are not in a vacuum without air resistance, there are situations where drag is so minor we do not include it. Shooting a basketball is one of these situations. Air having a density of around 1.225 kilograms per meter cubed, which when compared to another common object, water, having a density of 1,000 kilograms per meter cubed, we can see how minor this truly is. As well, a basketball is quite dense and is circular, making it much more aerodynamic, meaning it is not being affected heavily by drag, unlike something like a styrofoam ball or a feather, which will be affected much more. For those reasons, I have decided to exclude drag in my calculations. To prove that drag will not affect this calculation, I will be using this formula, which does not account for air resistance, to calculate time. I will then be dropping a piece of paper, which will be affected by air resistance, and show how long it truly takes for this object to fall, and then dropping a basketball, and show how long that will take to fall. Go. As you can see, the paper fell at a much slower rate than the formula intended. This is due to the air resistance. Go. As you can see, the basketball fell at almost the same time as the formula predicted. This is due to drag affecting the basketball very little. The reason it fell faster than the formula predicted would most likely be due to error in the experiment, with either the time not being started right when the basketball fell, or the height not being exactly measured. Let's start with some measurements needed to do these calculations. The NBA standard for basketball net size, ground to rim, is 3.048 meters. The distance from the free throw line to the center of the hoop is 4.9 meters. And the shooting height of the person used for the experiment is 2 meters. Now that we got that out of the way, we can begin. So, we're here with our subject, who has absolutely no knowledge of basketball, and he will attempt a free throw. As you can see, it didn't go in. Now, I will be breaking down the calculations I used to teach this man how to make a free throw.
Work come in, I'm moving. Ooh, work come in, I'm moving. Ooh, try how looking so stupid. Yep, try how looking so stupid. Move it, move it, move it, move it. Ooh, 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 work come in, I'm moving. Ooh, try how looking so stupid. Ooh, work come in, I'm moving. Ooh, try how looking so stupid. Move it, move it, move it, move it. Ooh, move it, move it, move it. Ooh, move it, move it, move it. Ooh, move it, move it, move it. Move it, move it, move it. Ooh, they acting stupid. Ooh, 100 on my wrist, Rick Rubin. Ooh, coming in the trap, I'm moving. Ooh.
Now, we will be putting this technique into practice as I teach our untrained basketball player how to shoot a free throw with physics.
Hey, 80 on my wrist. Ooh, 100 on my wrist. Deros, 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 deros. 100 on my wrist, bitch, I'm feeling like Deros. Part 4 Zans, I'm feeling like a hero. Superman, lean got me like Rio. And my auntie on P.O.
As you can see, my technique for the perfect free throw has turned this horrible basketball player into an excellent free throw shooter. He is now ready to join the NBA. This has been Visas Daniel with how to make a perfect free throw with physics.